Hello ladies and gentlemen, we're going to talk about random numbers in this video. Random numbers can be very useful in programs. There's lots of different reasons to use them. One reason that you might think of right offhand is in games. For example, Minesweeper, you wouldn't want to set the mines in the same place every time the game ran. You'd want the mines to be distributed randomly so the player had to guess where they were located. There's other reasons to use random numbers, but that's one good example. And the way we can do something similar to random numbers in C++ is with the function rand. And that'll return a random number, a random integer that's positive. In order to get this access to this currently undefined function, we need to include a library. And it's included in the C standard or std library or lib. So C std lib, C standard library. That gives us access to this rand function here. I'm also going to include IOStream, which will allow us to output our random numbers. And initially, I'm just going to create a loop here so we can output to the screen 16 random numbers. So for int index equal 0, index less than 16 plus index, that'll be our counting variable, and we'll have that included in our loop. And now we want to output these values, so I'm going to do cout whatever is returned from rand, followed by a new line, so each random number will be on its own line. So if I run this code here, you'll see I get numbers, all kinds of different random numbers, and there are in fact 16 of them. Now, one thing is, notice I said somewhat random or sort of like random. If I run this again, see it still says 41 at the top. We're actually getting the same random numbers, somewhat random numbers, over and over again. They're not really random numbers. They're what's called pseudo-random numbers. It's actually very hard to generate true random numbers using a computer because computers calculate things based on input, and for a given input there generally is a given output, and so it's very hard to do something random with a computer. But there is a formula here that is very hard for you to predict. So the formula for rand generates outputs a number that would be very difficult for you to predict given that you don't know any other numbers. And so one thing we can do is change the starting number for this formula, which is called the seed. And the way we can do that is with the srand function, or the seed of the random number. And we can give it a number here, like 10, for example. Any number would work. And it'll give us a different set of output numbers. So notice now it starts with 71 instead of 41. And I could give it the number 1000, and I'd get a different starting number and a different sequence of random numbers. So that's what srand does. Now, because I'm setting the same seed, I'll get the same random numbers again, pseudo-random numbers. See, 3304. I'll run it one more time. 3304 again. So once again, we still have the same problem, but we're getting different random numbers based on our seed. Now, it's helpful to set a seed and keep it for a while for debugging sometimes, because that way if you have a problem, you can repeat the problem. You can have the code do exactly the same thing with the same numbers for testing. So this is helpful to have a seed that you set. But what we might want to do is use a different seed every time we run the program so that we can have a different sequence of random numbers. And one very common way to do that is to have the program look at the current time and use the number of seconds in the current time as your seed. That way, every time you run the program, theoretically you're starting at a different number of seconds, and therefore you're getting different seed and a different sequence of random numbers. So the way to do that is to include another library, ctime. This gives you access to the time function. And so we're going to create a variable, start out as an int. That'll be our seed. And what we can do is store time here, and inside your time parameter you can just give it null as the parameter, or 0. Null is defined to be 0, so just pass it that. And that'll return an integer value. Now, one other thing we want to do is, well, we can say, so we're going to go ahead eventually and include seed here. And if I build this code, you'll see right here it gives me this warning, initializing conversion from time t to int, possible loss of data. The problem is this actually is returning and storing a signed value, but srand wants an unsigned integer for its seed, which means that it can't have negative numbers as a seed. Now, the time value generally is implemented as the number of seconds since 1970, since January 1st of 1970. So really, this time is always going to be a positive number, so we don't have to worry about data loss. But to get rid of the warning, let's go ahead and convert this to an unsigned integer. And the way we can get rid of the warning also is to explicitly cast it from an integer to an unsigned integer. So we're going to do static cast, and we're going to cast this, what this is returned, and the type we're going to cast it as is an unsigned integer. So now we have an unsigned integer. If we build the program again, we don't get that warning anymore. Gets rid of that. Now we're setting our seed, which is different every time we run the program, so long as we don't run the program twice in the same second. And as you can see, our first number here is 29458. If we run it again, 29478, run it one more time, 29497. So we're getting different random numbers every time with the seconds. Now, you might be asking, well, those random numbers are really great, but I might want a specific range of numbers, not just a number from 0 to who knows how large. For example, if I have a dice rolling game and there's 6-sided dices, I'd only really want random numbers from 1 to 6. How would I do that? Well, what you can do is you can limit the range of numbers using the modulus operator. Remember, modulus returns the remainder if you were dividing. So if I do this, if I say rand modulus 6, then it's only going to give me the remainders of our random number divided by 6. And our random numbers, when it's divided by 6, can only be 0 through 5. And so here, I'm going to get the numbers 0 through 5 no matter what. That's how we're limiting it, this number. So you can see our output here. You got a 0, you got a 5. We don't see anything that's negative, obviously, and we don't see anything that goes above 5. So no 6s, no 1000s, etc. So that's how we limit the range. Now, once again, I said I want numbers 1 through 6, not 0 through 5. It's the right number of numbers, but it's not in the right location. So what we do is we add the minimum number here. I'm just going to put this in parentheses so you can see it all together. Our minimum number is 1, not 0, so we're going to add that. And you can see now we get the numbers 1. You don't see any 6s in this particular output. Let me run it one more time. That's the beauty of random numbers. Sometimes you don't get a particular one. Here's some 6s. So we get the numbers from 1 to 6 in the output. Here's a 1 and a 6 right next to each other in this particular round. So we're getting different random numbers now, and we're getting numbers in our range. What if we want to make this generic so that we have a function that will accept the minimum and maximum number, and it'll output a random number in that particular range? That is something that could be pretty useful. So let's create that. So I'm going to have int, and we're just going to call it random num, and we're going to give it a minimum number and int maximum number, and it'll return a random number between that set using our random function, our rand function. So I'm just going to copy that prototype down here for our implementation, our definition of the function. Now, what might be helpful to store is the range of numbers. So the range is the maximum minus the minimum. That's, for example, in our 6-sided dice, the range is 1 through 6, which actually is 6, right? And so it's actually maximum minus the minimum plus 1, so 6 numbers. If we wanted to output the numbers 7, 8, and 9, the range would be 9 minus 7 plus 1, right? Because 7, 8, and 9 is 3 numbers. And if you can see here, 9 minus 7 is actually 2 numbers, plus 1 is a third number. And so that's the way of calculating the range of an inclusive set. So max minus min plus 1 will give us our range. So that's helpful because that's what we want to do our modulus by. So we can return rand modulus range, and then we want to add back the minimum. So once again, if it's 7, 8, and 9 we want to return, we want the first number to be 7. So we'd want to say plus 7, or in this case, plus the minimum. So, oops, semicolon at the end. So that's our random number function. That's all there is to it. It's got a specific range. Let's use that right here. We'll call it here. And let's go with that example. Let's say we only want 7, 8, and 9. So our minimum is 7, our maximum is 9. We'll run the code here. You can see that's exactly what we get. 7, 9, 8, 7, 8, 9, 7, 7, 8, 8, 9, 8, 8, 8, 8, 9. You can always tell a good random number sequence if you get repeated numbers. Humans, when they try to be random, tend to not repeat the number that was previously used. So that's a good example. Let's go back to our 6-sided dice example. So we want the numbers 1 through 6. Let's make sure that still works. Yep, we get some 6s, we get some 1s, we get everything in between and nothing outside of that range. This function will also work for negative numbers. So we can say, suppose we want negative 5 to 2, or let's just do all negative numbers, negative 5 to negative 1. So our maximum is negative 1. We run this code here. You see we get some negative 4s, some negative 5s, some negative 1s, nothing positive. So that's how we can get a random set of negative numbers. And it's all taken advantage of the fact that we have this range here. And we could also set it to be including some positive numbers. Let's say negative 2 to positive 2. Run that. And you can see, yes, in fact, we get some negative 2s, some negative 1s, positive 1s, that's 0. It's all within that range. So that is how you can do random numbers within a specific range. Hope this is useful. Let me know if you have any questions.